Hey everybody, welcome to week 6. We are getting on here towards the end. It's 6 out of 8 weeks of advanced programming with Java here at Portland State University. This is the home stretch of the course and the time where I hope people are realizing this is the advanced part of advanced Java. There's lots of new stuff. I think some say only 13 people here. You are the lucky 13 because let me tell you, as I said in chat, this is one of those ones where I think you want to watch live because we're going to be covering a bunch of stuff that is essential to your Project 5, essential to your Android, and I recommend that you play along at home. And if you're not in a position to play along, or you get behind or lost, just want to try things again, having at least seen me do it once, I think will be helpful. But I'm getting ahead of myself. So we've got some good stuff tonight. As always, we'll start off with Prime Minister's questions. Project 4, just as a reminder, you've got I extended the due date because a lot of people are still very much in progress, and I want people to be here focused tonight. So actually, more people are joining. We've got good. That's good. And so I want, everybody hopefully can put their Project 4 code down for a couple of hours while we make sure to get everybody set up with Android Studio and talk about the first project. Sorry, the first Android, the Android project, not the first one, the Android project. And then we've also got another mob programming kata for anybody who wasn't able to participate in last week's or just wants another opportunity to mob program. Always a good time mob programming. So we've got that too. But this is a lot of stuff. And we'll be exploring it together. I'm looking forward to it. But let's start off with Prime Minister's questions. So as I said, Project 4, still very much in progress. We've also got feedback on your Project 3 and things like that. So here at the beginning of class, what can I tell you? What questions do you have about things that you're doing now, maybe things that you've been reflecting on with regards to other things that have happened in the course? And again, for those of you just joining, we're kicking things off with the Prime Minister's questions. This is the time to ask your questions about Project 4. There's been a lot of questions on Slack and stuff, and I hope that's given people direction and that everybody is at least able to run the project out of the box with the client and the server. I hope you're getting experience working with servlets, with writing automated tests, both unit and integration. Yeah. Mm-hmm. Right. So that's a really good question. So the question is, hey, the integration tests, are they supposed to be just run independently of each other? And the answer is no. So, and let's take a look at that. And there's an important reason that the answer is no. And that is, let's see here, projects, I guess either one of them, project4.it, yeah. So now, unit tests, and just in general, is best when tests are idempotent, when they when they have all their own setup, when they do their thing and they validate and they have their own tear down. That's ideal because it's nice. It's easy to just reason about it. You know exactly what's happening. You're starting from a clean slate. You clean up after yourself, nicely self-contained. Unit tests ought to be this way. Right, because they're small little things, right? And usually it's just like, hey, a little bit of data gets passed into a method, and then validate that the right thing happened. Or in the case of your unit tests for your servlet, it might be a lot of stuff is reconfigured, and then you run your do get, and then you interrogate a lot of things, but still it's all self-contained. And that's because again, everything sort of gets torn down and cleaned up afterwards. Integration tests, especially these integration tests for that involve the servlet, involve the web application running on the server side. There you have more side effects. and purposefully have more side effects. So for instance, it's just the same way that in like your project 2, when you start writing to a file, all of a sudden the data persisted longer than, the invocation of your main method. Right? The main method returns, and if you write to the text file, well, now you've got a side effect. Now there's remnants of that test that are still around. The same thing happens with your integration tests as you interact with the servlet. So you have and so for instance, that's why. Oh, let's see here. I don't know if I have I don't have a good example, but one can imagine that you have a test that adds some data there, and then you have a subsequent test that relies on that data being there. Is it best practice? Boy, if you can avoid it, great, but sometimes you can't avoid it. And sometimes it makes sense, especially if there's like a lot of if it's a long-running test, then it actually becomes more, I guess, of a setup type thing where, okay, I'm going to create a bunch of data, but you can also assert stuff about that data. So I don't know, although based on what you were saying, I don't know if that's exactly what your case was, but to answer sort of the question that you asked, yes, it's okay, it's all right if they are not independent. And to enforce that, that's why we use this test method order method name, so that you know the order in which the methods are going to run. Unless you have one of this test method order annotation, the order of the methods isn't guaranteed. It really all depends on what the reflection API returns, and that's not specified. So this is why, if you do have dependencies among your test methods, you should use the test method order. Right, that's why the first one is like clean up everything that was there, and then go do a bunch of things. I guess I could also change this to be like an after, an after class or whatever it's called now. Basically, it's like do that. Actually, no, sorry, it has to be before class. Do that first, then run all the tests. Oh, that's a good point. Yeah, and so then Alex also pointed out that having this as a test on its own also makes it easy to just delete everything, right? Just run this test just on itself, and that will delete it, and then you can do other things with it, because there's not there's not like a URL that's exposed. Well, if you sent a delete to it, but you have to do that from curl or something like that, it's a little bit more difficult. Good question. Oh, also a question in chat. What should the output for this argument? And the input is --search customer name. According to the assignment, it's not defined what that does. There was some chat about this. I don't know, over the weekend or earlier in the week or something, and it does point out a perhaps a deficiency, but at least some confusing logic in the assignment. So here I have --search, and when we do that --search, it requires a customer name, a begin time, and an end time. But then to print all the phone calls in the phone bill, there is no --search. There's just the customer name. So these examples are what is the syntax that I will follow in the test cases. So it's my screen share is off. No, there, yeah. Okay, good, because it says I'm sharing my screen. I'm recording, right? I am good. Okay. Sorry. Oh yeah, this is what I'm going to. It's just not correct. It shows the home page. Oh, am I not sharing my entire screen? Maybe I'm not. Yeah, I think I didn't do that right. Sorry. Stop share. Share my entire screen. I don't know. Better now? I'm not seeing the line. Weird. Okay. It says I'm screen sharing. Okay. Sorry if that's messed up on the recording. But the point is that the examples here are the examples that match the syntax that I'm going to use in the test cases. So to answer the original question, --search with just the customer name is not something I'm going to test. The behavior of that is up to you. So you can just say, oh, yep, that must mean that they're searching for just the phone calls in that phone bill. So it behaves just like this example here that I've highlighted, or you can call it an error. I'm not going to test that situation. But thank you for asking. It's good to explore these things and that. Follow-up question, are we applying the delete method? The command line program does not have a way of invoking the delete method. So a delete method, to make a delete request of any URL. It's there for testing purposes. These are good questions. What else? How are people finding Project 4? People feel that they're making progress with it. I know there were some people earlier in the week that seemed kind of stuck. What have been some of your observations? What are some things, anything that you want to share with your fellow students in terms of things that you've learned that might save them some time or frustration? Yeah. Ah, okay. Yeah. 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 Okay, cool. That's good. That's a good way to get started. So what Alex said was he essentially rewrote to understand more about Mockito. He rewrote the test to sort of understand, hey, what do all the methods of Mockito do? How exactly do you program those mock objects to interact with the get method? And it sounds like then that gave you some enough experience, enough understanding of what was going on, so that you could then extend it as you built out your servlet to have it do new things. You should be a helper, yeah. Nice. Right. Yeah. Yeah. Okay. So exploring the HTTP helper to understand more about how the URLs get formed and all of that, and then good. Yeah. It's it's a way of debugging. It's a way of exploring it. And by the way, this is what you do with software. This is the I'm sort of thinking 85-90% of the code that I've looked at is somebody else's code. And and I guess one of another one of the meta lessons of the class is very purposefully, yeah, you need to figure out what my code does, what other people's APIs like Mockito or the Servlet API do. This is an important part of software engineering, and I can tell you, you will be a better software engineer. You'll enjoy what you're doing more if you can very rapidly and quickly understand the context. It's a skill, and one that took me a very long time, but one that I realized that early on in my career, like when I was in graduate school, I inherited a big project and had to figure it out, and I still use those same techniques in terms of doing things like okay, I'm looking at this code, like how do I figure it out? Getting good as a debugger, getting good at writing unit tests and stuff for code that you didn't write. Great skills to have. Jacob, you raise your hand. Sorry, let me get you on the right speaker here. I don't have the speaker. There we go. Cool. Yeah, Jacob?
Is there a better way to get error messages from the response structure? I know in the servlet there's the codes to send error, but that API code is hidden in the HTTP servlet response class. And so is the only way to pull an error message, is it in the HTTP response content? Is that the only way we can access error messages, or is there another method we're supposed to be using?
That's a great question. I am looking for an example. Maybe I don't have. Okay. Yeah. Mm-hmm. Mm-hmm. Right. Yeah. Yeah. So yeah, what Ariel was saying was for the oh sorry, where's the servlet test? For Mojito, you can get that. Well, let's see here. Actually, for the error message, are the error messages written to the print writer? I don't remember. The error messages are oh okay right yeah the error messages are written to the print writer. So for like a unit test for your servlet, you can just send in a real print writer like this example here and then get it. But I think Jacob, your question is more about like an integration test.
Or no, because the print writer writes to the content of the message. So it's mixing both data and error messages, and the only context you have is by comparing return codes. And I don't know if
Right,
there was
which
a
I
better
believe
way of
all of
doing it.
that. Yeah, I think that is taken care of by this throw exception if not okay HTTP status. That's a good point. Yeah, to just be clear, are you talking about unit testing with Mojito, or are you talking about integration testing?
Just all of the above. Unit
Because
test,
I think the answer is
integration test.
different. Yeah. So Alex, I mean. Oh, I see. So you would do something like capture not only set status, but you would capture set error. Nope. Yeah. Okay. Yeah. So again, the print writer, you had it print to the print writer. So yeah, I mean, and this is yeah. Let's see here. Let me look at the send error code here. Yeah, I mean, send error writes to the print writer. So yeah, I mean, I think the way that you would do it is that just like this example here, where we're asserting that the captured status code is okay. I think in your case, you would assert that. So let's say, hey, you're missing a required parameter, so you would assert that the status code that's captured is the precondition failed. So was that 403 or something like that, or something 412. And then you would also look at the contents of the, in this case, a string writer that's wrapped around the print writer to verify that it's got the error message that you expect. But Jacob, what did you end up doing to and did it work? Or are you asking because you haven't gotten it squared away yet?
I was literally just pulling the content directly from the response.
And I think that's okay. Because that's the whole idea in HTTP. I mean, you only have so many tools, right? You've got the status code, and then you've got the body of the response. I suppose you could also put in a header or something, but that's a little non-standard. So, the fact that it's sent with the non-200, the non-OK error response is a clue to the client that's like, oh, what you're sending me back, the A, it failed, and then it's going to look, and or at least our client looks for the error message in the payload of the response.
Because
yeah, Alex, do something else. I'm sorry, Jacob. What?
Because I found two ways of doing it. One that took more code was you'd pull the print writer directly from the response and then analyze it from there. But there's also the method called a get content. So I was mixing the two.
Oh, okay. Well, the get content I think is available on the that's for the on the client side, right? So we're talking about the like with the response object that you get on the client side.
Right.
Yep. Okay. So there, I mean, the intent is on the client side. So this is for the integration test. The integration test, you have this throw exception if not okay HTTP status. And I think we found last time there was one that was missing. I mean, it was on the get or something. Here, if the servlet returns something that's not okay, then it will throw one of these REST exceptions. And so then if you have an integration test that tests the phone bill REST client, then what you would do is you would do an assert throws, go off and call the method of the REST client, and then assert throws will return any exception that is thrown, and then you can interrogate it by calling get message on the REST exception to then, which is then the content that's put back. But it sounds like you got something working, which is good and important. It could possibly be improved by leveraging the REST exception, message. Does that make any sense?
Yes, yes.
Okay. Yeah, one more. Oh, yep. Yeah. So I was like to see send error. Okay. Being sure. Did you want a unit test or an integration test? Okay. Yeah. Let's do an integration test. Let's see here. We will get. Let's see here. If we try to put. Sorry. Yeah. If we add a dictionary entry, there might even be an example of this. Oh no, here we go. Okay, so here is the example of catching an exception. Yeah, so this is in the phone bill REST client IT. So here we send in empty strings for we want to create a dictionary entry, and both the word and the definition are empty. And in this case, it'll go to this missing required parameter, and it'll return a precondition failed. Okay, so okay, then I'll walk through this and then we'll go to a Makito example. Okay, and so then here, when you call add dictionary, you call it within the context of one of these assert throws. We say, hey, listen, I expect that the code that gets invoked here will throw a REST exception. And if it does, then it'll return that REST exception that's thrown. And then you can interrogate it and say, hey, listen, I expect that the status code is precondition failed and that the message is, well, this error message right here. Okay, so that's how you do it on the with the client, with the integration test. And now if we look at the servlet test, let's see here. Let's write the same. Yeah, let's write the same test, which actually shouldn't be too hard, I don't think. I think you basically just need to say, let's see here. Add test. What do we expect? We expect that missing. Yeah, but yeah, actually, so yeah, missing. Well, creating dictionary. Creating definition. We'll call it a dictionary entry. Creating definition with missing parameter, returns, well, results in, and sorry, what was that? That was precondition failed. Precondition failed. So we are going to create our servlet. And actually, I'll just do all this. Shall do all this to up to here. Yep. So copy all that. So here we're not going to have any parameters defined. They'll be empty. And let me probably throw some exceptions here. Cool. And now when we do post, let's see here. We assert that. We need to capture the status code. And here, okay, actually, we need to capture the status code that is passed into send error, and we need to capture the message also. Sorry, what? That's where you got stuck? Okay, cool. And so then, and that will be on the response. So let's, oh, and can you capture both? I can't remember. So let's give that a try. So, so first let's try this. We'll capture the status code, and we verify that set status. Well, actually here we want verify send error with that and any string, I think is the, yeah, is how you do that. So let's run this and see what happens. I spelled parameter wrong. That passed. So now, can we, I can't, I was trying, this might not work. I had in my head that, that you can only have one argument capture per method call, but I could be wrong. Message capture, and then, yeah, assert that message dot get value, get value equal to, specified parameter, this thing, and then the parameter name will be word parameter. I think that's probably the one I'll report first. They're both missing, but. Nope, that worked. So the trick is 2 argument captors. Yep. So that's what you need to do. Okay, nice. Yeah, you're welcome. So, oops, example unit test of the send error method. Yeah, it's terrible. Okay, nice, awesome. Hey, thanks for going into that. Again, this is the advanced part of advanced Java programming. Mockito and stuff, this isn't meant to be easy. This isn't like, oh, good, I did this back in CS200. No, right? This is the new stuff, because now all of a sudden we're getting to much more complex things in the course. And Jacob, thanks for your comment about the most fun I've had all term. And glad you benefited from the extension. Hey, listen, it's been, things are really hectic right now. A couple more days, I can accommodate it, and hopefully it gives you the breathing room so that you can be engaged tonight, because we got some cool stuff coming up. But before we get to that, any other questions for the Minister Prime? Nope. Okay. Let's talk about, okay, so we're gonna, so I'm, during the lecture part of class, we're gonna talk about Project 5. This is the final project. And this is really the culmination of the phone bill application that you have been developing all term. Right? Remember, we started out, it was just a couple of objects, and then we added the ability to write to a file, and then we did all the text formatting, and right now you're working on client server. Well, now it's going to be something completely different, which is you're going to be developing an Android application for your phone bill, and it's going to be in Java. And so then, I've always I've always had the last assignment be a user interface, because that's what we do these days, right? We have things that aren't command line, that don't read, of course might read some from files, but they have other forms of input. It's evolved, the technology that I've used has evolved a lot over the years. And what we're doing right now with Android. Android's cool because you get phone applications and you can use Java to implement them. But because you're developing an Android application and not a just a regular old Java program that runs on your desktop, there is a completely different tool set for it. Now, overall, and the tools are pretty straightforward to use, but my experience has been is that there's some amount of that there's work that we need to do together to make sure that everybody is ready to develop. I'm going to focus on that first tonight, and then we'll finish up, and I'll probably take a good hour and a half, if not more, to sort of walk everybody through that. And I do encourage you to play along at home. So please pay attention to what's going by. A lot of things will be going by. We'll be downloading some software. We'll be installing things. We'll have to put in the correct configurations and stuff. But at the end of and then we'll be creating a project. What I hope we get at the end of tonight, though, is an Android project that everybody can build. That'll basically be the skeleton of what we're starting. So there's not a script to create this. Instead, we're going to use the Android Studio tools to create the project. And then after that, I'll go through and talk about the requirements of the project. But first, let's get started. So the first, I'll open that new window. Sorry. Of course, now it's small again. Okay, the first thing we're going to do is visit this URL, and I'm going to copy this and paste it here in the chat. This is in the assignment, by the way, on page 2 of the assignment. And this is where you get started with creating Android projects. And the Android folks worked with the IntelliJ folks to make a Android customized flavor of IntelliJ called Android Studio. It's really nice for us. We've been using IntelliJ all term, or probably almost everybody's been using IntelliJ all term. And so the development environment for Android feels very much like the development environment you've been using for the rest of the course. And so I'm going to walk through is getting Android Studio all set up. So first thing we need to do is download and install it. So we do that here. So the latest release is 2021.2.1, and so I'm going to do that. And of course, there is a license agreement. I've agreed to this license many times. So, but of course, and on the Mac, you need to choose which chip you're using. So just be careful there. And it's like a 1 gigabyte DMG on the Mac. I'm sure it's pretty big on Windows too. So this will take a moment. Let me tell you a funny story. So probably, I don't know, 4 years ago, when I did this, I don't remember what building we were in. It was like an interior classroom, had no natural light. It was weird. And I had a room full of like 30 students, and then everybody tried to download the Android Studio at the same time, and it brought the Wi-Fi network to a halt. That was kind of funny. That's very funny, haha. But that made it rough. Actually, I think someone like literally went across the street to Starbucks and it worked faster. It was pretty funny. But luckily, you're all at home, and so then your bandwidth may vary. But here on the PSU machine, I only need to banter for 9 seconds or so before it'll be ready for me to install. So download Android Studio. I guess we could have been looking at all the pretty stuff that Android Studio does, but we'll look at that later. And then install it. And boy, just like release after release, year after year, they're making Android Studio easier to use. I remember the first time that I did this, there were a whole bunch of like sort of manual steps where you had to set things up. Everything is very nicely integrated now. And it's a good lesson in that people that develop software, you should make it easy for your people to use the software so that they'll use the software. Okay, so let's install this here into my applications. And there it goes. Just needs a few moments to copy stuff. Oh, and you know what also I'm going to do? Because I'm going to be running Android Studio and my Mac is pretty old by now, I'm going to quit IntelliJ, just take some of the load off my CPU and memory. Let's see, do I have any other apps I want to close? Nah. Okay. So then I'm going to launch Android Studio. Now, I run a number of versions of Android Studio on this machine, and so then your experience might look a little bit different in terms of the setup. My hope, though, is that it is familiar enough. Yep, I downloaded it for a reason. That the setup is familiar enough from working with IntelliJ that that there's nothing too scary if there's something that you don't see. Okay, so the first thing it says is no Android SDK. So if you watch the Android lectures and you haven't yet, please do, because it gives you the whole framing for Android and how it works. There are several pieces of additional software that you need to build Androids. And just the same way that you had to install a JDK, a Java development kit, to develop Java programs, you need to install and configure an Android SDK. And so this is all the tools that take your Java source code, and as we'll see, some other files too, for doing layouts and things like that, and turns it into an Android application that can then be deployed onto an Android device. So the first thing that we need is the SDK. It's asking for some components that you wish to install. API 33 is good, as is the base SDK. Actually, I don't know what that one's for. Okay. Oh, and it puts it there on your home, your local drive on the Mac. It's in your home directory, library, Android SDK. And like, hey, if after the course is done, if you need to save some room on your hard drive, it's got like half a gigabyte of stuff. And then once it's expanded, it's like 86 gigabytes. So lots of things. And here it just gives you more information about what you're downloading. There's the Android emulator and then all the SDK tools, and okay, that's all neat. And again, I go into a little bit more detail in the lectures, but okay. License agreements, of course. You are installing somebody else's software, and so then please be sure to read over this. Lots of good stuff. Basically, don't use their software to do bad things. And now it starts to download. Actually, we'll show the details so we can just see stuff going by. But it downloads a bunch of stuff from Google. By the way, Android is Google is one of the primary contributors to Android, and installs it. Yeah, question, comment. Thank you. Okay. So Alex mentioned he's got a Windows AMD machine. There's an additional piece of software, firmware. I don't know what it is, right? Yeah, software. Yeah, that is as required. Thanks for the heads up, and he shared the link to it off in the general channel of Slack. Nice. Thank you. And that's one of the things that I've come to realize. Android, and as we'll see, the emulator and everything like that. Oh, this is all done. There's a lot of cool stuff here. And because you're running an emulator, the Android emulators want to take advantage of all of the features of your machine, of your chipset, of your GPU, of your video card, all that kind of stuff. Oops. Interesting. And so then sometimes, yeah, you can install some more things. Okay, so here we are with Android Studio, and it's all started up. And let's see here. It's telling me it's got a plugin that I could update. I don't. Is there anything here? Not really. Oh, nice. Okay, Jacob, thanks for +1ing that AMD post. Yeah, it sounds like it's really important to do. Other things won't work. Otherwise, things won't work. Good to know. Okay, so now you've got Android Studio. And the first thing you want to do is create a new project. Now, in your previous assignments, you used the create script to get you all started. Here, we're going to use Android Studio to create a new project. So create a new project, and it's basically giving you all these templates for phone apps that are, and it gives you a choice of what are called activities. Now, an activity in Android apps is basically a screen that you're looking at, and we'll see. You can watch the lectures and learn about it. We'll see some more of it next week. That your application consists of multiple screens, right? You do something on this screen that brings you to a different screen, et cetera, et cetera. And those are all activities. I recommend that we're just going to start with an empty activity. You can also use basic activity. And as a matter of fact, probably most of this stuff isn't terribly interesting for your for your phone bill. I'm just going to start with an empty activity and go from there. So, okay, I want it to be an empty activity, and now you need to tell some information about your activity, about your application. So I'm going to call mine phone bill. The package name, please make sure that it matches your user ID. And here, you also need to say, here's the directory where I want the package to be created in. So I'm just going to call it phone bill Android. The language, is going to be Java. There's also a language called Kotlin that can be used to develop Android applications. It's basically like Java with some slightly different syntax for things, a little less verbose in places, some other language features. Great, it's not advanced programming in Kotlin, it's advanced programming in Java. So we're going to use Java here. And then the minimum SDK, let me make sure, I'm pretty sure 29 is right. I want to make sure I get this right though. So here we are using version 29. So there are different versions of the Android SDK and the Android libraries, and just like you have different versions of the JDK. So version 18 versus 17 versus 11 or whatever. Same thing with Android. So we want 29. Actually, it's kind of cool. It tells you, hey, there's approximately how many of devices that are out there will run that, and of course, Android knows this because every Android device phones home and gets things from the from Google Play and whatever, right? That's what they call the App Store, right? And things like that. So Android has all this kind of stuff, which is cool. Okay, so API 29, good to go. And so I click go, and now it'll download more things that are required for the projects based on the platform and then the API that you've chosen. And so then that was nice and fast. It went and did all this stuff. And then it told you, where it installed things too. So again, this is just all good to know. Okay. So it's all finished, and now it's going to open up the project. Yeah, Alex. That is next. So now it's created some files. We're going to look at the files after it's unloading, and so then you can see it's doing all sorts of stuff here because it has created a new project and now it's getting ready to build it. It's starting up IntelliJ. It's analyzing all of the things, and hey, it's IntelliJ, and so it's giving you tips of the day and things like that. And I think most of the stuff is actually IntelliJ things. But anyway, I like these little tips of the day, and I encourage you to go through them too because it'll tell you how to use the software. Okay, so then now Android Studio is telling you Gradle project sync in progress. So our projects, our Java code so far has been built with Maven. And Maven is really good at what we've been using it for, right? Building simple Java applications, even building web applications. It does the right thing. And the Maven conventions have helped us quite a lot. There is an alternative to Maven called Gradle, which is more modern and has a different build file syntax. And also, it has a very different philosophical view when it comes to builds and build systems. Gradle gives you a lot more flexibility than Maven in terms of what steps are taken. Sorry. Question from Yuri. What package we're using? Just like the other projects. So please use your login ID, your username. So mine is edupdxcs410jwhitlock. Yep. Gradle is the tool that is used to build Android applications. They chose it because it's more modern, because it gives you a lot more flexibility, and it's just something different. So okay, that's good. Question from Brian: should this be in the same directory that we've been using? It's going to be in the same repository. So yes. And so I probably should have taken a screenshot or something of that configuration. But yeah, let's go see where it is. So as you can't see if you're in the room, I created it here just in my checkout of my repository, and now let's just go ahead and add the code. So git add phone bill Android. And it says we could do this from IntelliJ also. So maybe I like doing it in IntelliJ. Oh, but I don't have. Oh, right. It's got this old version of Git. Okay, so yeah, I haven't updated the Git on my machine, so maybe this won't work. So maybe the Android Studio integration won't work for Git, which is unfortunate. So I'll fix that. Oh no, wait a second. It's got the Git tab down here. Oh, okay. Well, you can either. I'm just going to do this from the command line. I guess that'll be easiest. So I'll just add that directory to Git, and so now my status. There are all my files, and we'll take a look at what these things are. But let's first get things into version control. So I'm going to say git commit added Android project. Git push. So yeah, so then it is, and so then, well, we all know that Git works. So I just push it up to GitHub. So now I created the project in my repository, and by the way, I mean I'm doing this for the same reasons that I always have, right? I want my code under version control so that I can easily move it in between machines, and so that I can easily go back and revert if there's something that gets broken, either by me breaking it, or as we saw, there were a couple of people that when they went and merged the upstream changes. I have it right here. I was supposed to cover that. Don't let me forget to talk about that, because you can't submit your project 4 correctly until you have merged upstream changes. I will do that after the next break. That's because I didn't follow my checklist. Got so excited about Android. Okay, anyway, so what we've got now is we created a new Android project, and it's got a bunch of classes, and we're using Android Studio where we can see all sorts of good stuff. It's got this main activity, and then it's got a bunch of Gradle scripts. We're probably not going to pay too much attention to that tonight. I'm just going to close it then. And it's got a whole bunch of stuff, and this is all these are the kinds of things that you need to develop an Android application. So you've got some Java code, you've got a bunch of XML files. We'll take a look at some of these in a little bit, and then you've got some display strings, everything like that, and then you've got Android Studio to help you do everything that you're doing. So we've got our application. What can you do with your application? Well, you want to be able to build your program, and then you want to be able to run it, right? So so you're building a phone app, a small device app, or building an Android app. How do you run it? How do you interact? How do you make sure that it does what you want it to? Well, you need to run it, and you have a couple of options. I mean, if you have an Android device, you can actually plug it into your laptop, and you can, you can move it that way. But it's prohibitively expensive to go out and buy like every Android device there is to make sure that it works. And so, what the Android folks do is that they require device manufacturers to provide software emulators for their devices. And all the emulators are available free to developers, which makes sense, right? If I have a hardware device, I want to make sure that people can develop on it and develop for it. So, so after you've built your project, in order to run it, you need to have an emulator. And so then, well, let's see here. Let's try to run it now. And now this is IntelliJ, right? So we have the run with the run button. So you go and click it, and it says, "Oh, no target device found." Well, that's good. Now let's create a device. So if you look under here, there's something called the device manager, and it's also over here in the button. And what this does is this manages devices. Duh. Right now, there is nothing there. We want to create. Oh, yeah, I suppose you can hook up a physical device, either one that's plugged in via USB, or I guess you can pair using Wi-Fi. Well, that's neat. But we just want to have a virtual device. This is how I'm going to test your projects. So then all I'm going to be showing you is using the virtual devices. So you click Create Device. And then Android Studio says, great, it looks like you're trying to create a device. Here are all of the devices that I know about. And so you can get emulators for Android TVs, for watches and stuff, for cars. It's pretty cool. You can also, I suppose, create your own and import if you've got something else. But what we're going to choose I believe it's the Pixel 2. I have this again here in the assignment. Pixel 2 API 29. Yep. So Pixel 2. It's kind of old by now, but it works, right? Let's just go with something that works. Okay, we're going to want that. And then, so we'll choose that one. And now we choose which system image, version of the operating system, basically, that you have. And we want 29, we want Q. And so we're going to download that. And boy, Android Studio makes it super easy. Remember, the first time I did this, I had to go through so many Stack Overflow articles to figure out how to do this sort of on my own. But they make it really easy, although it takes a while to download. But here again, what you get out of this stuff is really easy access to all these different emulators for all these different kind of devices. And the intent here is that depending on the target devices that you want, you can test out your app. So maybe you've got an app that works on both on a phone, form factor of a phone, a small device, and then also a tablet, something a little bit larger. And we don't really go into it here, but what you can do is have your application detect what machine, what screen resolution, what screen size it has, and then behave differently, right? Think of some of your favorite apps that you might use on multiple devices. The canonical one I always think of is like YouTube, where I'll watch it on my phone and I'll watch it on my iPad. And it's the same application, right, that you download from the App Store, but it knows enough about the device that it's running on to display things a little differently, to make sure to take advantage of the screen and of any other features of the host device. And so, and of course, you can develop all of this using, you can develop an app that runs on multiple devices by having multiple emulators. We're not going to do that for this course, but I've got to say something while everything is downloading and unzipping, so that's what I just told you about. Oh, good, and it's done. So no more marking for time, at least not yet. Okay, so that downloaded and installed that system image, so basically that OS, that then gets imaged onto the virtual device. I mean, seriously, this is like the same stuff. There's like some amount of magic here, but a lot of is the same software that goes on the actual device that you would buy. And okay, so now that we've downloaded the operating system, downloaded the system image, we're going to create the virtual device, and I'm just going to call it Pixel 2 API 29. It'll start up in portrait, et cetera, et cetera. And then that button down there says finish. Okay, and so then it goes off and it creates an Android device. And then you can start it by clicking the triangle. And let's see here. Come on. Yes, please. There you go. Maybe. Huh, I thought I'd be able to click that and have it work. Well, oh wait, there it is. I probably clicked it too many times, got confused. So, so when you start the emulator, you're literally, it's like starting up the phone. And so, and then you get, and I'll try making it a little bit bigger here by hiding some of this, and then I'll pop it out here in a moment. You have the phone emulator, which runs the phone software, right? Is that base image, running emulator. You've got this here. In a moment, we're going to deploy our application to that, and you'll see that's like it's running a phone on your computer. And you can then interact with it the way you want. Now, hey, the phone's got to start up. And remember, this is a phone emulator running on my almost 10-year-old Macintosh, so things take a bit of time. They probably take a little bit of time on your machine too. But that's really hard to read. I'm going to make it bigger. Let's see here. How do I do that? I say view mode window. There you go. Now it's in its own window. I can make it bigger. There we go. Oh, now you can actually read it. Okay, this is neat. If USB debugging, sure, I'll just say always allow from this computer. That resolution's kind of crappy. Okay, great. And you've got a phone. And you can interact with this phone like it's a phone. So you can click on the screen with the mouse. So you can launch Google Chrome on the emulator. And here again, this is running the actual phone software, the operating system, and it comes pre-installed with a couple of apps like Chrome, and you're doing your thing. And so then it can, let's see here. Sure, I can send you usage statistics, whatever. I will not turn on sync. So here we go. Oops. And oh yeah, here's a link that's on my keyboard. Cool. And so look, I can use a web browser on a phone emulator. And so it is, making a network call over, using my machine. And again, things are kind of slow, probably because it's putting a lot of stress on my machine right now. Don't worry, your application, it won't be doing very much. It won't be doing nearly as much as this. So anyway, so it's doing its thing. And you can click and drag to scroll. Of course, I'm using my mouse instead of using motion gestures. But then you've got the 3 buttons just like on any Android app, and so then you can click it, and then you can flick it up to terminate the app. So I've got my emulator. Now I want to run my application on it, and so the way I do that. You'll notice that now that I've created my device, I've got this one device under the run configurations. And now I can just click run app. And what that will do is it'll build my app project. And the first time it takes a little while. It's got to build a whole bunch of things from scratch. Oh yeah, and as someone points out, you can use the keyboard on the emulator. Absolutely. Not this week, but next week we'll see how to how to create a simple user interface and enter in some text and things like that. So we just search here too. You can say oops. Okay. Yeah, so like Android. Oops. Cool wallpapers. And you've got like a virtual keyboard and things like that. Oh, interesting. Jonathan says that he has to turn on turn on virtualization for Windows 10 and Intel. Good to know. And then Alex? I'll talk about the requirements of the app a little later on. Let's. I want to get it working, and then we will take a break. And I'll talk about more details. Okay. So Android Studio built the app and then deployed it off to the phone, and here we go. Here is the phone built app that we created. I am not happy with that screen resolution. There we go. Gosh, it's really hard to read. I don't remember. It didn't used to be that bad. Well, it really isn't anything to do in this application. But hey, we've got it running. So let me do a quick recap. We installed Android Studio. We created a project. We committed that project to GitHub. It's got a bunch of files and things like that. Then we use Android Studio to download and configure an emulator, so a virtual phone that runs on your PC. And then we built the application and that deployed it to the phone, and now we can work with it. And now, granted, there isn't that much to work with in this phone, but next week we'll change that. Yeah. Oh yeah, right. So then, yeah, what was that? The device frame. Okay. Oh yeah, it actually does look a little better. Thank you. Yeah. And oh, there's a couple more cute things. I like. There's a whole bunch of neat configuration that you can do. You can, I guess you can click the buttons from up here. You can rotate the phone. You can adjust the volume. You can power it off, but also, oops, there's the extending controls, which and I don't know, maybe I'm easy to impress or I'm getting older. I thought this is really cool. But what you can do is you can set all this information about the phone like it's a real phone. You can, you can tell, you say, hey, when you're using, when you're using cell, because you can configure your phone to be like in cellular mode, use an LTE network or use a GSM network. And you can say, hey, but what if I've got like a weak signal or no signal, right? And then you can like test your phone in all of this. I don't know. I still think this is really cool. The fact that as a developer, I can I can test all this stuff. I can make sure that my app does the right thing for all of this, right? You can install various fingerprints and stuff in there. You can oh yeah, the record and playback. That's cool. And so then you can record interactions and stuff. I think this is fun. I think it's pretty neat. You can tell it, hey, here's where the location is, and so then, hey, maybe your app like sends you an alert, like when you're close to a restaurant, or you're close to one of your friends or something, right? You can test all of this stuff. So anyway, fun stuff there. After the break, we're gonna dive into the details of the assignment, but anything, any questions that we have before that? Actually, sorry, I had a question. Are people playing along at home? And I see some good conversations and stuff, but in general, are people able to get things running? Or are you like, wow, this is a lot and I'm going to do it later? Yeah. Create a new project, and I did like a blank activity. I think it was, yep. Yeah, or basic activity. Empty activity is what it's called. Thank you. Empty activity. Yeah. Okay, and it looks like a couple of people have got things running. Excellent. Oh, good. Yeah, I had to clear up some space. Yeah, it's this is not compact software, Android Studio and everything. You're doing a lot, and so it's not surprising that you need a lot of tools, you need a lot of disks, you need a lot of memory to run it. Okay, then. Let's take 13 minutes. So we'll be back. Yeah, and definitely. I know I went fast through the setup. That's why it's all recorded. And let's take 13 minutes. We'll be back at 6:45. Okay, and we are back. So at the beginning of class, we got we walked through how to get our Android Studio environment working. We installed the software, we created the project, we put the project in GitHub, we ran it, and now what we've got is this application running here. And it sounds like most people were able to be successful. A couple of people have been working with me to get everything working in their environment. That's good. That's good to hear. When I started doing this, it was a lot more difficult. They've made it much easier, and that's nice. So let's see here, 6:47. Let's spend just a tiny little bit more. Let's spend a little bit more time exploring the project and what we've got. So we've got the here over on the right, we've got the app. And how does this thing work? Or how does it all get put together? Well, let's look at the source code that we have for all of this stuff. And let's hide the device manager to have more real estate. So Android applications are a mixture of Java code, like this main activity here. This is a Java class, and then various configuration and what are called resource files. And Android Studio knows all about Android applications and Android projects and all the source code, and it lets you work with it. Gives some nice tools for working with it. So for instance, if we look at our application, we have things like this word phone bill up here, and then we have a simple blank area. This is the activity, the main activity. and it says hello world. Now, the way this is represented, how the object is represented, is something called, is an activity. So again, activity is a screen, and activities consist of a Java class that represents the activity. Here it is, the main activity. And then also there is an XML file which describes the visual layout of that activity. And so then the convention is, well, actually, is the convention activity main activity? No, I'm pretty sure all of that is configured here. Yeah, here in the in this Android manifest. You're not going to change this most likely, but this is much like the WebXML for your project 4. It's a configuration file that tells the Android SDK that builds your project things like, hey, what's the activity to start with, and here it tells you about the API. It has the label for the phone book, and a bunch of other stuff which probably isn't so interesting. I don't think you'll have to change that. The XML file, which can either be navigated to from just the file browser, or Android Studio lets you click on this link over here in the gutter. It'll take you to the XML file here. This is actually what the XML looks like. This is a representation of the visual component, the visual aspects of the activity. In particular, it's got this text view in it with the text "Hello World," and so then when we look at the phone bill, it says "Hello World." Well, if we're going to change that, if we change that to hello CS4, well, hello advanced Java, advanced programming with Java. And then we, I'm used to this all being different applications. And then we go and we reload. Let's see here. Apply changes and restart activity. What this will do is it'll recompile your project and deploy it off to the Android emulator. And sure enough, now we have updated that text. So this is how the build process works. You make changes over here in Android Studio to your source code, either the Java or the XML, and depending on what exactly you change, sometimes you can do this like easy deploy, which is apply changes, restart activity, and other times you just need to like redeploy the entire app. Android Studio or the emulator or someone will tell you, it's like, oh, wait a second, you need to rebuild the whole thing. We'll see some examples of that later. We've got this view now. I want to call it IntelliJ. Android Studio, highlights things that are a little suspicious. Like right now, it's got this yellow highlight over this text message here, and it's saying hard-coded string hello advanced Java programming with Java should use an @string resource. And so just like with IntelliJ, you can, for me, it's Option Enter, but you can take action on it. And so you can say extract string resource. And what that will do is it'll take this string, this hard-coded string, and put it in something called a resource file. I'll talk about that shortly. And it will, this is a refactoring, and so it will, let's see here, it'll give you the name and value of resource. I'm just going to call this hello. What did I just do? I don't know. I'm going to call this hello, and it's going to have that value that gets extracted, and it's going to put it in the main resources in a strings.xml. So cool. No more warning. Now it replaced that hardcode, that string constant, with a reference to @string.hello, and you can navigate to that by hovering over it and hitting Command or Control, and you click into it. It'll bring you to this configuration file right here. So this is a resource configuration, and what resources are just files of text. In this case, it's actually display strings. But you could have numbers in here. You can have colors. There's examples of it in the lectures that are used by your application. So the reason that it's good to put your resources in resource files as opposed to hard coding them in is so that is for localization, right? So you could have another resources file that's localized for a different language or a different country language combination, a locale, so that your application can display text in people's native languages. So depending on how the phone is configured, for the preferred language for the user, they'll be able to see strings in your application in the language they want. And of course, it's a good thing because our software has a worldwide audience now. So I have, so now I've made this change. I've refactored. I suppose we can. Let's see here. Can I do the apply changes and restart? I might be able to. Yeah, I guess this one still works. I'll change it again. Oh wait, no wait. It said unable to perform. Okay, so here, right, I wasn't able to do the quick deploy. I guess I just need to do the full run of the app. Oh, and it looks like it has a translations editor. That's kind of neat. How does that work? This is new. Oh, I guess you can provide some translations. That's kind of cool. Show all locales, and then I guess you have to create a locale, add a locale. Ooh, this is neat. Anyway, but not for now. There are no requirements to translate your application into different languages. I'm sorry, I want to say hello again. Oh, let's now let's deploy that again, and we'll see it running. Oops. Oh yeah, sorry, it basically shut it down, and now it's going to redeploy it. And here, great. There's the change. Yeah. Yep, at string hello. Yes. So as we'll see, resources are oh, interesting. It's at string. Yeah. Okay. And basically, yeah. So this defines a string here, and so it's at the string named hello, and so then at string / hello. Like HTML. Yeah, or like XPath or something like that. Yeah. Yep. Yeah. I mean, we're all influenced by by things. This is what makes sense. Yep. So anyway, okay. So I'm going to commit these changes, and so then oh, I have a slightly different. How do I do this? Can I? Oops. Okay. So I've made these two changes here, and so now I can commit them to Git. And so then extracted the hello string to a resource file. And I can push that to GitHub. Now, there's some other stuff here. So here in the XML file, the top of the XML file is something called a constraint layout. Now, if you watch the lectures, you'll see that there are two types of visual components in Android. There are views, and then there are view groups. A view is a widget, so something like a text field or a text label, a text input box, buttons, images, all those kinds of things are views. You get a view into something. And then there are other objects that are called the view groups, whose job is to lay out other views, right? So let's say that you want to have a bunch of views all in a row. Well, there is an object that will lay that out for you. And you can learn about it in the lectures. I'll talk more about it next week. Oh, yeah, I don't know much about Bootstrap, but I'm sure it's the same thing, right? Where you've got a container, which probably contains other widgets, and then it says how to lay it out. I want this to be in a grid. I want this to be in a straight line, or like, give this the most room, and then have things around it. Yes, it's the same. These are very common patterns in user interface development. So your text view here has all sorts of information. As a matter of fact, oh, anyway, I'm not showing you the super interesting thing. So anyway, so you have this XML representation of it. And okay, the XML is just that, and so you can sort of see what everything's going on. But what's more interesting is if you go into design view. Actually, it's even more interesting when you can actually see the damn thing. So let's minimize everything else. So now you've got essentially, WYSIWYG. What you see is what you get. Editor, and you have both. You both have the light and the midnight, the dark version of it. Can I hide that? So what does that do? That toggles visibility and position. What does that give me? Zoom fit screen. Oh, that's kind of nice. Anyway, and now you have a way of adding stuff to your UI. It's kind of easy. It's a nice thing to do. So you can put a button here. So you can get a button and you can just like drag it onto the canvas here, and you can put it anywhere. And we're just gonna. And so now over here on the right, you can get information about it. And you can see that these widgets have all sorts of different properties in terms of how they're configured and what they do. I'm pretty sure you can search for things. You used to be able to. Come on, where are they? Can I? Oh, here we go. Search. And so you can say things like text. And now, okay, great. Here is the text of the button. So instead of button, can I actually double click and edit it here? No, I can't. I have to go over here and add it. Should be able to just start typing for search, by the way. Was that a question or a statement? I don't know. Maybe it probably is. Let's, I don't know, stop this. And then if I escape that and I'm just like sitting there and I say text, no, not for me. Not special. Maybe I have to do Control F or something. Yeah. And now I want to say click me. And now I change it over here, and now it adjusts it there. Yeah. Question? Sorry? Yeah, I thought this was like dark mode, like midnight mode or whatever it was, but yeah, actually it's the same activity. It just looks, this is like dark mode versus light mode. I thought so. Oh, I don't know. Yeah, I've always kind of wondered. Actually, what is this right here? Oh, that makes it bigger. I did not want to do that. Oh, my button and everything. Oh no, what did I mess up? Oh wait, I messed something up. You know what I can do? I can go back and look at what has changed in the file. So yeah, so what it does is it keeps the XML in sync. And so as you can see, oh, I added a button, and okay, there's the changed text. Actually, it's complaining about some stuff. It's probably saying that's not anchored or something like that. So what's that red? Missing constraints. Come on, tell me what's wrong. Oh, interesting. Oh, there it is. No, that just tells me what a button is. Oh, no, there it is. This view is not constrained. It only has design time positions, so it'll jump to 0, 0 at runtime unless you add the constraints. Yes, it will, and let's deploy it and see that in action, because it's something that I always get messed up with. So it is applying the changes, and look, the button is here at the origin because we didn't tell it how it should be laid out. And so then, even though it's like right here, see these little accordions here? Those are the constraints. And so then, let's see here. I'll just have my button there. But what we can do is we can change the constraints. How do we do this? I always get move this one down here, and then move this one up here. Good. That looks a little better now. So those are the. Oh, maybe not. Is this? Oh, I always get that confused. Can I delete that? Yeah. Now I want this one to be constrained here. I want this one to be constrained here. Come on. Oh, and then this one is, I thought there was a way. And then this. So now that's in the middle, but then this label. Come on. plus constraint. So now I want this one to be relevant relative to there. Did I get it? No. Just gotta find the right place. Ah. Oh no, maybe that's okay now. So that one is relative to that. Let's see if that. Oh wait, it's got a warning. What is it? Hard-coded text. I'll fix that later. So now if I go back to the code, oh good, there's no more red thing. And by the way, it's changed some other things too. It's given that one an ID. Okay, that's neat. And it's complaining about this the text here. Oh wait, the text is button. That's not right. I thought I changed it to click me. Huh. Oh, I think I undid that. That must be what it is. Okay, so now it says click me. Here I'm going to zoom in. Yep, there it is. And now I'm going back to the code. It's complaining about this string, and so I'm going to fix that again. Extract the string resource, and I'll say click me. And now, yep, no complaints about anything. A couple chats have come in. Saying that the blue squares in the upper left corner change whether or not that blue view is there. I think sorry for delay. I think it's a blueprint view or something. Okay, yeah, I've never used it either. Yeah, so anyway, yep. Yeah, I went through it pretty quickly. This allows you to localize. It allows you to translate them into different things. If it's just hard coded there into the XML file, into the activity, the layout XML file, you can't localize them. And that's why Android Studio is like, nope, put them off in their own file so they can be localized someday. Yeah, localization thing, accessibility. It's Yep. It's what Android Studio wants you to do. You will listen to Android Studio. You don't have to listen to Android Studio. It's. I'm not gonna take off any points. I'm pretty sure I turn off the linter when I build it. So we did a bunch of work here in the design view, and actually let's deploy this so that we can see our handiwork. This is. It looks like, okay, here's another one of those, like, hey, we weren't able to simply just reinstall it, or we weren't able to simply deploy it. We had to do a reinstall instead. And so now so it rebuilt it, and now the click me is in the place that we want. So this is cool. Note that now I have to go back and forth to the XML so I can see what was changed. So as we went and did things in design view, like when we moved the, sorry. And is this actually that fit view? Yeah. So when we did things like, put the constraint arrows or the accordions between various things, it went and updated the XML to reflect that. And so it changed some things like the margin on the bottoms that used to be, actually it didn't used to be there, and then it put one there. And then of course it added the button. And then changed all these layout constraints. And so these are all properties of this constraint layout, and you can go and look that up. You can also, if you look at the lecture notes, there are some more straightforward layouts that you can use. Anyway, to get everything, this is how this is ultimately the representation of the UI that the Android SDK is going to work with. Is this XML file? Android Studio has a really nice visualization of it. Okay, how are we doing on time? 7 o'clock. Okay, so let's commit this. Added a button. That button right now, not very interesting. Let's make it a little bit more interesting. Let's make it more interesting by adding an on-click handler. Oops, on-click. Okay, so developing code for user interfaces is, okay, sorry, seeing lick there is a little weird. Click. Developing code for user interfaces is really different from other kinds of code in that your program, it's kind of like a servlet in that, like, when the servlet starts up, it just sits there waiting for someone to interact with it. And user interface code is the same way, right? Your Android application is starting up, and it's like, play with me. I'm a fun person. Like, interact with me. Click my button. Screw me with a scroll bar. Right. And it's waiting for someone. So what your Android application does is it responds to these interactions. So when someone clicks on the button, your application is going to do something, and you need to tell your application how to respond to that button click. And the way you do this is you register handlers, or event handlers, on the various widgets. All of this is in the lecture notes, and so I'm not going to go into too much detail here. But I'm going to show you how you can do one of these things. So then say hello. So what you can do is on the button. So I click the button and I went to the on-click property. And you say, hey, listen, on click, you then give it a method name for it to invoke when it's clicked. So I'm going to say hello. And then it goes, oh, I just happen to have my changes there. And so it added that property to the to the XML file. And it's like, well, you told me to invoke a say hello method, but there ain't no such thing, right? Luckily, Android will create that for you. Create say hello in main activity. Yes, please. So it then adds a method to your activity class. So each activity has a Java class that has all of the logic for the activity, and then it has the XML file which has all the layout for the activity. And now when you click say hello, when you click hello, it'll invoke this say hello. Now, when I say hello, I want to do something. And so I am going to make, I'm going to make something called a new toast. Now, a toast is, well, we'll see, it's just a little pop-up. And then I'm going to say hello. And it's going to be short, and I'm going to show it. And that was, and so then toast is an API, Java API, that you can call from your activity. And now, oops, I'm going to, come on. Sorry, Zoom is in my face. I'm going to redeploy the app. It's going to start up again. And now when I click me, my little toast popped up down here. It said hello. Right. And so this is how what we're doing is we are connecting interaction with our widgets to doing stuff in our application. Okay. So this is pretty neat. Yeah. Sure. I'll walk through that again. So the first thing I did was I was over here in Design View, and I was looking at my button, and I searched for all of the properties that have click on it. And there's something called on click. This is all in the lecture notes, but the whole idea is that on click is the name of a method that is invoked when a widget is clicked. And so I did that, and then that went and changed. So the Android Studio then added that property to my button object here in my XML file. And then it was underlined in red because IntelliJ, or I'll call it IntelliJ, Android Studio didn't know what that say hello method was because it hadn't been created. So I did Alt Enter, and it said, would you like me to create that? I'm like, yes, you would. And so then it created it on the Java object that backs the main activity. Right. But is it working for you now? Okay. Oh, yeah. So I think it was smart to figure it out. Okay. But this is a good way to do it. Alternatively, what we can do is, well, I'll show you the alternative another time, because there's one more thing I want to demonstrate, and then it's time to go on some other stuff. So, okay, so now we've made some more changes. Let's see here. Say hello when the button is clicked. Okay. So I call them screens, but yeah, they're like pages. They're more interactive than in my mind. Pages, the word I use is screen, but I think conceptually, if a page makes more sense, that's fine too. Yeah, like a settings in an app would be a screen. Yeah. Yes, that's an activity. Yeah. Yep, with its own layout and its own Java class represents the logic of that screen. Yeah, and so actually, we'll when we talk about the assignment, we'll sort of I'll give some a method that I like to follow to design these things and sort of figure out how to develop things. Yep. I do want to get to that, but there's one more thing I want to show. Okay, so what we've just seen here is how you can use Android Studio to design your UI. And by the way, there's a whole bunch of different widgets that you can use. Right, you should do like a phone number widget and things like that. There are different layouts that you can use, different containers. I don't know how many of these are actually going to use, but it's lots of cool stuff. So I encourage you to be creative in this and explore these. And put everything under version control, because I found it's really easy to get things completely screwed up, and 10 minutes later, I'm flipping up the table, I want to try something else, and if everything's under version control, you're all good. And then you can have the widgets, and then you register handlers on the widgets to get information to then. Sorry, let me go back to my activity. Sorry, and it's like say hello as a handler. You can then handle user input and clicking buttons and typing text and things like that in these handler methods. Your application is going to work with phone bill stuff, and so you will need your classes in the project also. So you're going to want to copy your phone bill classes, and when we talk about the assignment, we'll see exactly which ones you'll need. Copy that in here, and so then you'll need your phone bill. So I'm going to create a new. Actually, let's create a new phone call. Okay, I would love to add that to Git. Thank you for asking. And you'll recall that that it extends abstract phone call. Abstract phone call. It's red. It doesn't know what it is. One of the important things that you need to do is tell your code about my code. Now, Maven took care of all of this, but here there's a different step for Android, and that's talked about. That's here. We need to add the following in the app/build Gradle file. Oops. So I'll go back here and I'll find in the Gradle scripts. I think it's this one. Yeah, under dependencies, we need to add this thing right here. So here with the implementation, we need to add this. Oh, what doesn't it like? Oh, it has funny quotes. Sorry about that. Here we go. As your Gradle files have changed to the last project sync. Project sync may be necessary, so please sync now. And so now I changed my Gradle file, and just like when we changed the Maven file, Android Studio needs to sync all that up, make sure that it can still build. Everything looked okay. So now let's go to phone call, and now can I import that? I can import that. Good. This will be important, right? You want to use my code, my abstract phone call, my abstract phone bill, my text dumper, all that, or that, yeah, the phone bill dumper, all that kind of stuff. You've got to take this very important step of putting your implementation inside that build.gradle. Okay, so now I've got a phone call. I'm going to make myself a very easy phone call. We're just going to we're just going to create all of those. I'm just going to return some dummy data here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, whatever. And then get callee return 2, 3, 4, 5, 6, 7. And then get begin time string 1/1/2022 at 1 p.m. and get end string 1/1/22 to 2 p.m. So now I have my phone call object that uses abstract phone call, phone call. And now I want to do something with this, and I want to use this in my UI. You're of course using your UI too. But now my main activity, in addition to saying hello, actually instead of saying hello, what I will do is I will make a new phone call. And let's see here, new phone call. My phone call doesn't have any parameters or anything like that. And I am then going to just put in call dot toString, or I'll just say this. The call is, and then put in call. And now I'm going to redeploy my application. I'm going to rebuild and redeploy my application with this class that I create a new class, and it references one of my classes. And now when I click me, good. It printed out the toString to this class. What I want to demonstrate is that we can use our classes in our Android application. So again, I now have the toString from my, I'm going to change that to be, it's not, I don't want length short, I want length long. Once more, can I just apply the changes? Yep. And now if I click me, good, it displays for a little bit longer. Yeah. Yeah, and remember you have to use plain old quotes. I think when I copied from the PDF, they got fancy quoted. Yeah. Yes, right after that, we're going to talk about the requirements of the assignment. And you'll probably see it's like, oh, okay, I need to use that code. Oh, I need to use that code too. Yes. Oh, don't worry. There's you'll be using some code from Project 4, but you'll be using your servlet. So there's no servlet involved here, but you will be using some other stuff. Okay. I'm going to commit these. I'm going to say added the ability to use a phone call that extends David's abstract phone call. Nice. Okay. Oh, and there's chat. Can we see that phone call at Java again for a sec? Yeah, sure. No problem. It extends abstract phone call, and then I just like overrode everything real quick just for the sake of expediency. And then, as probably a number of you will recall, abstract phone call has a toString that then calls all those methods. That's where the output of the click me comes from. It's just a toString of the phone call. So that was a very brief and admittedly very fast walkthrough of Android, of developing the Android application. So as you saw, we looked at the XML file that contains. Sorry, it's big. We looked at the XML file that contains the visual. It describes the visual layout. We could see design view where we could actually add widgets and position them and things like that. We then added a new button, and that new button has a say hello method. Or rather, when the button is clicked, it invokes a say hello method, which is implemented on the activity. And when that method is invoked, it is invoked when the button is clicked. It creates a little toast thing, which pops up a little message. And then we augmented that toast to display the toString of a phone call being a class that extends one of my classes. We had to augment the build.gradle to include the dependency on my classes. Right? Yeah, it's almost like computer programming. Oh my gosh. Yeah, lots of stuff there. Exactly. Yeah, it's different. Yeah, and I hope it's I hope it's exciting. So let's turn back to the project and talk about the requirements. Now that you've seen the kinds of things that you can do with Android, what are you going to do with Android? So this is the final phase of our phone bill application. We're going to be developing a small device app for the phone bill, and I hope this gives you an opportunity to be creative with Android to develop a user interface. I'm sure there are a number of you who have never done this kind of programming before, and I like it. It's fun. It's way more interactive and more, I find, more more rewarding than just oh, look, some text on the screen, or oh, it's processed a file or something. So the requirements are actually pretty straightforward. Unlike the command line argument where it's like you have to have these arguments and stuff like that. There's a lot more creativity here. Oh, question from Yuri. So just to clarify, is the Android project going to be built separate from the Portland State Summer 2022 directory you've been working with? Let's see here. When you're committing changes, where are those going exactly? Sorry, I missed that. When you're also setting the project, also when you commit changes, are the please don't. Okay, no problem. No, and I went pretty fast. I'm going fast tonight. I had some caffeine. Oops. Let's get to that question because it's a very good one. It's very important. So, your Android project is source code. Source code should be under revision control. I recommend that you add your Android project to the same repository that you've been using for everything else. No reason to create a new repository, and that's what I did. So when I created the project, I created it in my checkout of my summer 2022 repository. As you may recall, I added on the command line. I added that directory. I created it in phone bill-android. I added it to Git and then pushed it up to GitHub. And so and there it is. As you can see, if you look at my commits, the ones that I've made tonight are all about adding the Android project and then the various things that I did. So yes, please. Here again. You want your code under version control. Use the GitHub repository that you already have, but it's not. But the Android project will not be built by Maven. It's built by Gradle. Okay, cool. Thanks for double checking on that. That is a good question. So when I commit all my changes, they go up here. So back to the requirements of the project. So the Android application should have all of the functionality of the previous assignments. The things you don't love. You're creating a phone bill and adding some calls and pretty printing it and searching for calls. However, there's no REST API involved, right? So there's not going to be a servlet. This is all going to be a self-contained application. Although you do get to write the text files again. So those of you who are missing file I/O, you have your hands. Oh, now I'll be doing it in Android. So you don't need the servlet, but all the other functionality is there. Just some things about the entry point. So like that first screen, there should be a help menu with a way to view the README. Now the README, it'll be text, but it won't, obviously won't be written to standard out. It'll be displayed in an activity or on, in a text view or something like that. So it's a README. So by now you ought to know what should be in a README. And really that's it. So make sure they can do all the stuff from the other projects. There is no servlet, and the only real constraint I have on the visual interface is that, well, you can view the README easily, and it is reasonably intuitive to use. So I say be creative. Don't be so creative that you end up with like the Pablo Picasso UI, and it's like, oh no, wait, the text field is over there, but it's rotated, 235 degrees, and it's all in, it's all in Cyrillic or something. No, please don't do that. Just, I grade these. There are a lot of you. I spend like an entire Saturday just grading these things. And one of the things I grade you on is the usability, and I think yours is truly hard to use. I will dock you points. So, also, if something goes wrong, the application shouldn't crash. It shouldn't try to write to like some log file I can't see or whatever. Pop up a dialog box. Use a toast, something like that describes the error. Or you'll visually indicate that the data that you entered is invalid. And note that if you are going to use pop-up dialogues like toasts, it should only be used for conveying small pieces of information. Don't put your README in a toast to look really ugly. Or your pretty print or whatever. And so then again, be creative, have fun, look at the various kinds of widgets that are out there, and of course, balance being creative and exploring things with actually getting the project done, right? You don't want to find yourself the night before it's due and like nothing's working because you've been trying to figure out how to embed JavaScript from web pages. Be practical in addition to be creative. Oh, question? Oh, yeah. Good question. How do I learn more about Android? It's probably not in the. Did I not put that in the assignment? Well, that link to the developer is like that. But let's say you want to look about like a text view. Let's see here. No, you want the Kotlin one. You want the Java one. So yeah, so developer.android.com, really great documentation. This is basically the equivalent of Java docs. Well, I guess they are Java classes and stuff. But yeah, they give you examples on how to do things, and they provide all of the descriptions of all of the properties of the widget, and then I also give you a bunch of methods and stuff. There's a class hierarchy. Again, you can view all of this stuff, or rather, you can learn more about this stuff in the lecture notes, in the lectures. Yep. Oh yeah, and great tutorials too. And hey, if you find a tutorial that you like, do your fellow students a solid by posting it, to the Project 5, which I believe I created, the Project 5 channel in Slack. Submitting behind the scenes is actually a different submit tool, and so because unlike with the plain old Java programs where I don't let you not only change the POM, and I really restrict what it is that you can and can't submit. Here, because there's all the XML files, because you do have to change the build.gradle, all that kind of stuff. I'm much more loose about what gets submitted. So just be aware of that. So it's okay to submit your Gradle code and things like that. Also, I don't expect you to run Android on the CS Department's Linux machines. You have to submit from there, but you don't run. There's no equivalent of running Maven Clean Verify on the CS Department's Linux machines. They don't have the Android tools installed, and that's fine, right? So they don't have the emulator, all that kind of stuff. It's not there. So I grade them on my own machine. So basically, run the submit.sh. Oh, this is yet another reason. That's right. Yeah, this is yet another reason to put it in your in the same repository in a folder called phone bill. Phone bill-android, because that's what the submit program expects. So you still use a submit script. So you have to put your code in GitHub, put it up to, and get it on the CS Department's machines and submit from there. Yeah, a couple of footnotes there. We talked about getting started already. A couple more things. It's important to note that that if your app crashes or I kill the app, that the data that's already been entered survives. And so then I recommend using that API, the write internal storage API, to persist phone bills information to the file system that resides on the Android device. A couple of more notes. This is how I'm going to build and run it. So you should make sure that all the stuff runs cleanly before you submit. And again, you got to run it on your local machine, not on the CS Department's machine. So do a Gradle clean to start over again, and then do a Gradle build to make sure that your project builds this is actually important. I'm not going to build it in Android Studio. I'm going to build it from Gradle. So make sure that the command line works there. And so Gradle W is just like Maven W. There is a lint step there that will sometimes cause the build to fail, which is what linters are for. So I encourage you to address the feedback of what the linter is telling you. But ultimately, what I'm not going to run the linters because I'm not going to like fail somebody because there's like no time to there's no time to resubmit this project, right? It is due, essentially at the end of the class. And so then I'm not going to when I run it, I use this command here, which doesn't do any of the linting. So you need to submit the app directory and then your Gradle files, which, by the way, the submit program should take care of all of that for you. Let's see here. Oh, and that a couple other things. No more tests. Yeah, you can write automated tests for Android. It's really cool. But I want you to focus on learning Android. And so then, writing the tests, yep, that's what we do in the real world. But you've already demonstrated, that you can write unit tests and integration tests in other projects. Same thing with API documentation. I'm not going to bother to generate it. You've demonstrated already that you know how to do that, so you've learned that lesson already. Yeah, it's about having fun. It's about like just using the tools. I hope you find that as fun. And by the way, this is what I'm going to use to run the emulator. So again, it's API 29. Please make sure that your code uses that API version. Anyway, so that's I'm telling you. Well, actually, no, I'm not telling you what grading script will be. This will be how I launch your application when I grade it. And those are all the details. We're going to dive back into Android next week and sort of get some experience. But between now and then, please make sure that your environment's set up. Make sure that you're that you can that you've created a project that is in GitHub, all of that good stuff, and watch the Android lectures and start learning about things. Because there's really a lot to learn. I hope you'll find it interesting and compelling. But there's a reason that this is due in 2 weeks. The 10th, the last day of class. Yeah, that's crazy. 1 week, 2 weeks. Yeah. Okay, so there's not a lot of time to do it. But it'll be fun. I hope it'll be compelling too. Any questions off the bat about Android development in Project 5? Nope. I want to filter through on one thing, and then we'll get to the mob programming. And that's the following. Okay. So, sorry. What will we cover in the final exam next week? Everybody keeps asking that this term. Although, I'll just say anything that I've taught you will be part, in the scope of the final exam. We'll talk more about the details of it, and things like that. But yeah, anything that was covered in the lectures is fair game for the final exam. Okay, I want to go back to the getting started. Yeah. Okay. I discovered a pretty serious bug in the submit script a little while ago. Say what? Yeah, I know, right? So much so that I had some PG level curse words here. in my commit message. Yeah, I'm sure. Like anyway. And basically, the problem was actually. Well, I'll just look at the change here. I messed something up pretty big. When I teach the 11-week version of this course in the winter, the web project, the REST project, is project 5, and Android is project 6. And I forgot to update the submit.sh script for that. And as a result, if you try to submit project 4, it thinks it's in the phone bill directory, not the phone bill web. Oops. And luckily, there were a couple of people that submitted early, and I went to run their program, and it's like, there's no project 4. I'm like, oh, please rename your project 4. They're like, I thought I did. What's going on? And I realized that the bug was on my end. So, oops. So, what this means for you is that you need to get this change into your submit script. And the easiest way to do this is the following. Well, easiest way. Actually, the easiest way probably is just to copy these changes. That being said, the right way to do it is to get the changes that I've made in my upstream repository, in the Getting Started repository, and get the change to your own repository. So now, if I go and I go to my summer 2022 repository, and I don't believe I have moved this down yet. I have not. So my submit.sh is wrong. It says that project 5 is the web. This is wrong. So I need to get those changes. Now, the way you do that is documented in the README. And if I search for the term upstream, there is a section here. It's called How Do I Get Changes that Other People Make into My Clone. So this is your clone. These are changes that I make. And so I've made some changes in the upstream repository that I want to then pull into my repository. And it's actually a pretty straightforward thing that you need to do, but a number of people have done it, and some people have run into some problems, so I wanted to make sure to walk through it with everybody. So the first thing that I'm going to do, and this is some Git magic, I'm going to add what's called a remote repository. And I'm going to say git remote add upstream repository. Oops. I'm going to hit copy first. So git remote add upstream. So a remote repository from a Git repository is basically like, hey, this is another Git repository that I know about, and I'm going to give it the name upstream. And here's the HTTP link. I prefer the Git links. So I'm going to do this. That's actually it's in everybody's repo. Everybody this is in the README, so you've got it in yours too. Oh, sorry, the upstream. Yeah. Sorry, it's the upstream is the Getting Started repo. It's the thing that you cloned, that you made that special clone of originally, that has all of my changes. But now, we've basically, they've diverged. You can think of it as forked. And so you've been making changes on yours, and I made a change on mine, and now we need to get my code into your repository. And because they're different repositories, it's not a branch. It's actually a separate repository, but they have this common ancestry, right? Because you created mine, right? You go look in your Git, your Git log, and you've got all my changes back to wherever it was 2018 when I created this thing. So it turns out I've already added this repository, because when I tried to add it again, it already exists. And so if I say git remote -v, it says, oh yeah, there's already one called upstream. Okay, that's nice. Got permission denied. Matt, what operation did you perform exactly to get permission denied? Was it on the merge of the Git upstream? Oh, okay. Git pull upstream. Well, oh, interesting. Which URL did you use? The HTTPS URL, or did you use the github.com?
Yeah, I used
Actually, those are the
HTTP.
wrong. Sorry, what?
Yeah, I just copied from the README.
Actually, that should be okay. Boy, I think you should be able to do it. Hold Try the for your origin. Do you have the git at github.com, or do you have the HTTPS?
I guess I have the HTTPS, but I'm not certain.
Okay, well, do the git remote -v and it'll tell you.
Yeah, it looks like it's the HTTP.
Oh, interesting. But you can push to it. You can push to yours.
To mine, yeah.
But you can't pull from mine. That is surprising because I mean there shouldn't be any permissions there to be able to pull.
That's cool. I can try the git.
Yeah, try that, and hey, worst comes to worst, you can just make the 2 changes that I made. But yeah, follow up with me in chat or something if it's not working for you.
Thanks.
Yep. No, thanks for speaking up. So you add this upstream repository, and then what you do is you pull the changes from the main branch into your local repository, your local checkout. And that will merge it in. I think that merges it in, right? Yeah. And so now, okay, you've got a new commit to make because you got all these changes. And so then I will merge there. Now it said there weren't any conflicts, which is, I guess, good. And now quickly, I'm just going to do a clean verify to make sure that everything still builds. Okay, good. I got the changes. Actually, let's just make sure that I got the changes to the submit script. Yes, the web is project 4, Android is project 5, so that's good. Git status. Okay, everything has been committed, and now I'm going to do a clean. Now, I think some of you encountered some merge conflicts when you pulled it down, and that's not terribly surprising, depending on because I made some changes to my README, I made some changes to my POM. And there were a couple of people over the weekend that did this. They encountered some changes. If things don't build after, well, actually, please make sure that things build before you do the pull and the merge. And then if things don't build after the pull and the merge, and if you spend more than 10 minutes trying to figure it out, please reach out because it's usually a pretty easy fix. Some people also mentioned that you can just go back in your Git history and just revert back to the latest version of the pom.xml that did work. The upstream changes to the pom.xml are not essential for the course. It was me trying to get the Maven site working. Oh, token permissions, that might be it too, but if he's able to push to his repository. Question, are we executing these steps again? If you've already executed them and gotten the changes to the survey.sh, so if you do a git log on the survey.sh and the most recent entry starts with the word damn it, then you're okay. Right, so if you do a git log survey.sh, yep, the top one here, it starts with damn it. That was the one that I fixed the bug in. My build was clean, and so then I'm feeling pretty good about this. So I'm going to push those changes up to GitHub. And now, if I go to, well, if I go to my submit.sh, right here it didn't have it, but now when I go to it, yep, I've got my damn it revision. Again, this is really important that you do. If you don't, when you try to submit project 4, it'll submit your project 3 code, and it'll just take another go around. I'm not gonna call it late or anything like that because it's definitely on me. But please make sure that when you submit, it is project 4. I thought there was something in the submit program that would warn about that, but it's probably easy to miss that warning considering so much stuff goes by. So Shrestha, you need, if line 32 of your submit.sh says if project equals project 5, then do phonebill.web, you need these changes so that project 4 is submitted from the web directory and project 5 is submitted from the Android directory. Good. Again, sorry about this, but bugs happen, right? But it's great that we can use GitHub to easily get this fix out to everybody. Okay. Next up, we've got our next mob programming activity, but we should probably, I don't know, do we want to take a break first? You probably all need a break. And then, yeah, and people that leave. So actually, are either of you guys in the room going to stay for the mob programming? No? Okay, cool. And okay, so that's it. Hey, just as a little preview, the mob programming will be this kind of neat little like RPG combat thing for us to work through. Actually, show of hands on the on Zoom. Who wants to stay around for mob programming? Just so I have a clear idea, because if no one wants to stay, we'll be done. Okay, there's 1, 2, 3, 4, 5, 6. Okay, so we'll have like 1 or 2 mobs. Sounds good. Okay then, great. So, comparatively short class tonight, but boy, did we cover a lot, right? We learned all about Android. We got our environment set up. I'm glad that it was straightforward for most of you. Hopefully that bodes well for your ability to do Project 5. If you're having problems with your environment, please reach out. Use that Project 5 channel in Slack. So we've got, and so then that project is due in 2 weeks. Next week we'll do some more Android programming. I'll show you some more examples, but please don't wait until next week to break ground on the project. I've got. We got the extension for Project 4. It's due on Friday. Yeah, maybe take a day or two to catch your breath over the weekend, cool off and everything like that. But there's a lot to Project 5, and so I encourage you to get started on that as soon as possible, because it's really more than a week. So don't wait until next week to start. Okay. Excellent. Okay. Well, so at the end of class, thank you for attending. Let's take a 10-minute break. We'll come back at 8 o'clock and do some mob programming. Okay, we're back, and boy, there's 11 people participating. This will be good. I think we'll have enough for 2 mobs. This should be cool. Okay, so our kata tonight is called RPG Combat. RPG is role-playing game, and this is a new kata. I haven't done this one before in class. It looks kind of cool. And also it's pretty complex. There's a lot of steps here. There's lots of logic here to implement. And so then the intent, as always, isn't to do the entire kata. It's to work together and learn about pair programming and to see what it's like to collaborate in this manner. So let's see here. I'm not going to walk through all of this. I posted a link in the chat. It's also on the homepage for the course under tonight's lecture. And but the whole idea is that you've got characters in a role-playing game to model. They have various attributes such as their health and whether or not they're alive or they're dead. And then there are more and more requirements in terms of like the level that they have. So after they've achieved various levels, they have more health. There are factions that you can that characters can be part of, that determines who's an ally and everything. There are also some magical objects. Again, we're not going to get all this done in an hour, but it's really about hey, figuring out where to start with a pretty complex problem, working together to make some progress and to get some stuff running. So it should be pretty interesting. In terms of your code, I encourage you to leverage this summer 2022 katas repository that I made. You can either commit to it directly, and if you don't have a push access, I can grant that to you, or you can make a fork of it for your own to commit your code, to share it with others, and then to provide evidence to the graders that yes, you participated in the mob programming. going to open up the breakout rooms here shortly, but are there any questions about tonight's activity? We're going to go for about an hour or so. I'll check in at 9 o'clock and see how people are going. Nope. Okay, then. Breakout rooms are created. I will open them all up. You can self-select into a breakout room. If you find, I don't know who is actually still engaged and who's not. So if you find there's only like, 2 people in your breakout room and there's 3 in the other one combined, right? You want to have a mob of at least 4 people, and really 5 or 6 is ideal. But here we go. So please feel free to join one of the breakout rooms and do some mob programming. Hey, we're back. So I poked my head a couple times. It was really exciting. It sounded like you all were doing some great work and having some great conversations. And so I just wanted to report out and hear about what your experiences were. If there was anyone new to mob programming tonight, I'd like to hear about that. But I'd also like to hear from the people that were returning for the second time. How was different this time than it was last week, either because the kata was different, the people we were working with different, or just different about you. So room number 1, which is Camilo, Jonathan, Mark, Richard, and Tram. What were your experiences like, and what would you like to tell the other team, the other mob, about your experience tonight?
Sure, I can talk a little bit. Yeah, I think we had a lot of fun. Once we got past I think all getting sorted out with code with me, then we were good to go. And everyone brought really good ideas to the table. I think we were everyone caught at least one small error at some point, and we were oh yeah, good call. Yeah, that's a great point, and we fixed it. I think in my past experiences with mob programming, I've been the intern who doesn't know anything and everyone else knows everything, and so that always felt like a lot of pressure. But this felt really collaborative, because I feel we were all working at the same level and able to collaborate really effectively. It was a good time for sure.
Awesome. Thank you for sharing that, Jonathan. Anybody else from room 1 have anything they want to share, or observations they'd like to put out there?
I just think it's
totally.
cool. Oh, go ahead.
Oh, go for it, Richard.
No, I was just
Probably
saying, I
all
think
want
it's
to talk.
cool because it's watching somebody else code is kind of spending time in their head. And I think it's cool to see how other people think about things versus how you think about something.
Nice.
Yeah, totally. I was going to say I totally vibed with what Jonathan was saying about being the intern in the room. It was nice to kind of be on the same level and everybody kind of bouncing off each other a little bit. It was really cool. It was fun to be writing tests while it was being coded, and just really getting some good time just being the tester. I don't know, I really enjoyed that actually. It was cool.
Nice.
Yeah.
Cool. So yeah.
Oh, I was just gonna add, it was really good each time that I did it, because I did it last time, and this time, each time I learned something new or learned something that I knew about, but I didn't actually know how to write and code out and everything. So it was really fun to watch and learning experience.
Nice. Cool. So did you take a test-driven approach, or you had tests? Did you write your tests first, or did you find yourself following on? What was natural and what made sense to you all?
We started with test-driven for sure. And then I think just kind of as we started getting comfortable and understanding how we're working together, I feel the tests were almost happening simultaneously as we were writing methods. It was pretty cool. It worked pretty seamlessly. It's almost exactly when the method was done, the test was done, and we run the test. It's all right, everything is working. So I feel we found a pretty good system.
Yeah, it was really cool.
Nice.
We were just
Yeah.
kind of going simultaneously at the end. So I was writing the tests, and then I'd be oh, what's this method going to be called? And I'm guessing what they're going to call it, and they're writing it at the time, and I could see the red go away. It was really fun.
That's pretty awesome. Great. That sounds like an awesome experience. I'm glad that you all got to experience that here in the second mob programming activity. Room 2. That's Ashley, Joshua, Matt, Nicole, and Tace. What were your experiences? For the first timers, what was it like? For the returners, what was it like? What was new? What was different? What was the same?
Personally, for me, I was a first timer, and it was a pretty good experience because similar to like what we had in my programming one, there was at least one thing that I could say I learned that I took away with, and that was because with you're not allowed to deal damage to yourself, right? So like as we input the object of the parameter, we have to into the function, we have to kind of like make sure are they equal or not. So learning how to check if objects are equal or actually, I found out it's a lot simpler in Java than what I was thinking of because I'm more used to like JavaScript, and checking for equality could be like really tricky in JavaScript. So when I saw how it's done in Java, I was like, oh, this is a lot simpler than I thought it would be. So that was one thing that I learned. Yeah, and we did test-driven development. So we had a running joke because I was the one writing the tests, and then like someone else would write the actual methods. When I would write the test, I'd be like, "Oh no, the test failed. What can we do about that?" And then someone on the other test would be like, do it up, and then like the whole Bob thing. Looks like we have a passing test. So yeah, I felt like our group gelled well together. We didn't make fun of each other for our spelling mishaps, which could happen at this late in the evening. So we're patient with each other.
Nice. Others?
Yeah, it was a fun experience. First one I've done. Definitely takes the pressure off having so many people working on the same problem.
Yeah. To add to that, I feel like it's easier to pair program because with pair program, because it's just the two of you. Like, if one of you is a driver, one of you is the navigator, you kind of take those roles a lot more seriously. Where if it's just like a lot of us together, there's like a lot more minds could come together and kind of handle these responsibilities off and on. So I felt like that helped more people, the better. As long as it's not like 10 people, then you could have like so many people shouting. But like a good group of like 4 or 5 people is a great number.
Great, excellent. Anybody else from room 2 have something they'd like to contribute?
I thought it was really fun. I too, in my internships, am often the one coding while I have more experienced developers kind of guiding me along the way. So it was nice to all be on the same level. So I definitely concur with that. Yeah, it's also tough, like trying to manage, like you don't need to comment every time you see a little error. They're gonna catch it because I can just kind of get in the way. So adjusting to that as well. But yeah, I thought it was really fun.
Excellent. Great, good deal, everybody. Well, hey, that's our second and final mob programming activity for the summer. Thanks. I didn't know people were going to stay around. I'm glad there were some second timers in addition to people who didn't have a chance to do it last week, and I think it was a good time. So, if there's anything else, I think we are done for the evening. If you haven't done so already, please be sure to fill out the reflection. It's a quiz on Canvas. That's due next week. And I encourage you to do it though pretty shortly while all this stuff is fresh in your head. So have a great evening, everybody. We will we'll see you next week. Bye now.
Good night.
All right, everybody.
Thank you.